All right, Panthers, this is from the multiplying fractions lesson, which just occurred on the 15th last week. So, wow, check this out, because today I'm recording this on the 19th, catching up. This is one important skill. This is not multiplying fractions, but this is a skill you need in order to do multiplying fractions because they're going to give you a mixed number like, what's 1 1/3 times 3 7/4? And you're going to have to like convert those things to fractions because that's what you need to do. To multiply fractions, you want them both in fraction form, not mixed number form. So that's what I'm trying to tell you here. So take a look at this. What do you notice? What do you wonder? You know, we're talking about mixed fractions turning into fractions, mixed numbers turning into fractions. How do we do that kind of thing? How do we make that kind of thing happen? How do we take this mixed number here, 1 and 0 halves, and turn it into 2 halves? How do we take 1 1/2 and turn it into 3 halves? Now you can see the picture. 1, 2, 3, you can count it, but what if you get some really big numbers that you don't want to like draw pictures and count? So we're looking for a pattern so we get some kind of rule, an algorithm, right? What kind of algorithm can we use? Let me pull this back here. And just, I encourage you, as Cal, I stole this completely from Khan. Khan is a hero for sure. I encourage you to stop the video here, pause it, and look for some kind of, what do you notice to start with? What do you notice and what do you wonder about this? Okay, well, if you haven't noticed, I'm going to point something out to you. Maybe you have noticed this, and let's use green and blue, I guess. So look at this. This is a 2, that's a 2. This is a 2, that's a 2. Is that true for everything? What if it's not a 2? What if it's something else? Oh, if it's a 3, it's a 3. So right away, for our algorithm, you can say whatever the denominator is in the mixed number, that's going to be our denominator in the fraction. Huh? I think we could be pretty safe about that conclusion, drawing that conclusion. What else do we notice? I'm noticing that, well, this is weird. This is tough. Where does this 2 come from? Where does this 3 come from? I don't know how they're getting that exactly. This is, and then I do notice it keeps going. 3, 4, 5, 6. This is 2, 3, 4, 5. This is, oh, so I do notice 4, 5, 6, 7, 8. I know they're increasing by 1. Oh, that makes sense. They're increasing by 1/4 because in the picture you can see it. Here they're increasing by 1/3. They keep adding a third on. But what if we didn't have the picture? How would we know just from looking at, say, this, that this is going to be 4/3? Just from looking at this, that this is going to turn in, like that top number is going to be a 5. What can you do with these 3 numbers to make that top number 5? What can you do with these 3 numbers? By that I mean, not numbers, I guess, the 1, the 3, and the 1. Digits, whatever, parts of numbers. What can you do with those 3, let's call them numbers for now for the sake of demonstration. What do you do with those to get 4? What do you do with these 3 to get 3? I do see you can do 1 times 3 to get 3. And this one I see you can do 1 times 2 to get 2. But it doesn't work for this. This would be 1 times 3, but this is not equal to 3, it's 4. 1 times 3 is 5. Wait a minute. 2 times 3 is 6, so it works here. And that's a 0. I wonder, okay, I'm starting to think something here. Oh, look at this. Right down here, check this out. 1 times 4 is 4, and there's a 0. That 0, so 1 times 4, let's see, let's look at this one. 1 times 4 is not 5, but it's 4. Aha, I figured it out. 4 plus 1. 1 times 4 plus, I think that's it. Let's see if that works. 1 times 4 plus 2 is 6. 1 times 4 plus 3 is 7. 2 times 4 plus 0 is 8. That's it. Wow. Okay, let's see. What's this next slide here? Why do I have this? Is this the exact same slide twice? By golly, it is. Okay, let's look at it here. Let's see if this makes sense. Okay, the 3 stays a 3. All right, so this is going to be here, this down here, everybody, right down here, right down here. This number here is going to be a 3. A 3. See if I could put a 3 there. Yep. But how do we do this? We said, okay, 3 times the 3 plus the 2. So 3, so it's the whole number times the denominator plus the numerator. If I color code this, let's see if that's going to help us out. Let's color code this. The whole number times the denominator plus the numerator. I'm going to color code it right over here. The whole number, right, times the denominator plus the numerator. There, that's our formula. And if we plug it in, the whole number here is 3, the denominator is 3, the numerator is 2. So let's solve it. I'm going to go up. No, we'll go down. What's 3 times 3 is 9. 9 plus the 2 is 11. So this top number here, this 11 goes right here as our new numerator. And then we can verify that by counting. How many thirds do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It works. Makes sense, right? Here's 3 times 3. Yeah, 3, 6, 9. That's our 9. Plus the 2 more. Plus the 2 on that are left over. Aha, beautiful. It's a wonder. You try it. See what you get. All right, did you remember our formula? Whole number times the denominator. I think we did denominator in green. Plus the numerator, which we did in purple, should give us that's our top number. But we already know the easy part that this is 11. So you should already have that lit right away. Boom, 11, 11 stays the same. Oh, that reminds me. The character on Stranger Things, which I'm watching now, is called 11L. Okay, just in case you didn't know that. Now you do. Okay, so we're going to plug it in. 5, plug in the formula. 11, 11. And then 3, what do you get? 5 times 11 is 55. Now still add the 3 to that. 55, 56, 57, 58. 58 goes on the top. Is that what you got? 58 is our new number, which is the formula right here. So let's just put this, yeah, let's just check. Should we do another one? Oh, Mr. Hoffman does this one? I don't know why. Oh, because when you multiply, you need to have fractions. You said that is a fraction. No, that's a mixed number. This is a fraction, so that can stay like that, 6 over 7. But this needs to change. So we're going to do whole number times the denominator plus the numerator to get the top, our new top number. And right away, we know our new bottom number is, that's easy, see? Right away, you know that for our improper fraction, we're going to convert this to is a 2, because it's a 2 here. So 3 times 2, 3 times 2 plus 1 is what's going to be on top. And so that's the 3, the whole number, times the denominator plus the numerator. And what do we get? 3 times 2 is 6. And then, so 6, we still have to add the 1 to it, plus 1 is 7. So it's going to be 7 over 2. And we're going to multiply that, and our 6/7 is still the same. Now you can multiply that out, right? Which is 42/14, which could be reduced. You can also do 42 divided by 14. But I want to go back and show you one of my favorite things in the world to do is when you see something like down here, right here, like this, look at this as just maybe one fraction, where you have 7 times 6 on top and 2 times 7 on the bottom. And what's awesome about this, and one of my most favorite things in the world to do, is cancel things out. Abracadabra. For every 7 multiplied on the top, you can get rid of one of the 7s on the bottom. So now, instead of getting this like 42/14 kind of junk, I'm going to erase that because, you know what? I can just get rid of it, except for, wait a moment, because, the computer's like still blown away by this. It needs to process this amazing mathematical trick I did, mathematical trick. It's like, wait a minute, Mr. Hoffman, really? Even me, the computer, is wondering about how amazing this is and how brilliant you are with your canceling and how just awesome that powerful it is. So really these are like you got to treat it like it's gone. So really this is kind of gone. So really what we're left with here is 6 over 2 and that's so much easier to deal with, right? We can just do 6 divided by 2, 6, right? 6 divided by 2, 2. And I know that 2 goes into 6 3 times. See? Divide, multiply, subtract. So I divide. Now I'm going to multiply. What's 2 times 3? 6. Now I'm going to subtract. What's the difference? What's left over? 0. So the answer is a 3. Isn't that nice? 3. 3. Hopefully I did that right. Again, on this one we're not going to do. It says simplest form, so that's nice. I'm not going to do the whole thing, but you should get right away. You got to turn this here, and we'll circle it in, I don't know, blue. This needs to be turned into a fraction. Now you can leave this one alone because it's already a fraction. In order to multiply, you need to have both of them to be fractions. Okay, actually you don't. There's another way of doing it, but it's got, I think, a little bit longer and harder. So let's just go with this way for now. And if you're really dying to know the other way, then email me and I'll show you the other way too. Okay, so 3, 4 stays the same. Okay, so let's do this. We said whole number. Did I do that right? No, I want that orange. Let's stay consistent with the colors for now. So let's see, orange, purple. Right away, our new fraction bottom denominator. That's the easy one because it stays the same. If it's 3 here, it's going to be 3 down here. Now, the top, let's make a little bit of room. Slide over, slide, oops. I don't want you to get bigger. I want you to slide, will ya? Let's try that again. It's not wanting to cooperate. I'll have to use my mouse instead of my pen on this one. Yeah, it cooperates better with that sometimes. That's supposed to be a little dot. Let's just kind of fix that really quick. That means multiply. Okay, now we got it. So we're going to take our whole number multiplied by our denominator and then add the numerator. And let's fill it in as our formula. 3 times 3 plus 2. 3 times 3 is 9, plus 2 is 11. Oops. So that's gonna be our new top number is 11. Turn that into an 11. I'm just gonna erase it here and change it to an 11. You might need to rewrite it somewhere. 11 over 3 times 3 over 4. See, now you can do that really easy peasy thing where you just kind of go 11 times 3 to get your new top number, and you do, oh, wait a minute. Oh, I can cancel out again. I could do 3 times 4, but look at this beautiful thing I love to do, and I hope you learn to love it too. Just look at this as a fraction. What can cancel out? I can cancel these 3's out. If there's a 3 on top, a 3 on bottom, bye-bye. So now all I'm left with is 11 over 4. That makes life so much easier. 11 over 4. All right. And now if you want to, turn this back into a mixed number, if it asks for it, simplest form. I mean, this is pretty simple to me. I think this would be an acceptable answer. But if you're doing multiple choice, what if this is not one of your choices? What they're looking for is some kind of mixed number, right? So, some kind of mixed number. So let's see, 11 divided by. So I draw the house. Here's the house. 11's inside the house. The top number's inside the house. The bottom number's outside the house. Okay, 4 goes into 11. So we're going to divide, multiply, subtract. Divide, multiply, subtract. 4 goes in 11 2 times, because if you did 3, that would be 12. That's too much. So, and then now we multiply. 4 times 2 is 8. And what's the difference? Subtract 8, 9, 10, 11, 3. And if you're going to make it a fraction, the denominator, the terminator, I'll be back. I'll be back. What color have I not used? Let's go with red. The denominator goes on the top. No, not denominator, remainder. This is a remainder. Oh, red for remainder. The red remainder goes on top. What rhymes with bottom? Oh, blue. Blue, not rhymes, starts with the B. B starts with boo, blue. Boo, boo. It is almost Halloween. Well, they have Halloween stuff out already, and it's just the beginning of September. Oh, it's the middle of September, end of September. Anyway, and they have Christmas stuff out. Can you believe it? It's the end of September. Christmas stuff is out. Anyway, boo, blue, boo, blue. Okay, bubbly blue. Buble. He's a singer. Okay, so that's going to go down here. Put blue on the bottom, red remainder on top. I'm gonna use white just because it shows up really nice like this. 3/4, right? See what I'm saying? See how that white comes out really nice like that? For aesthetics, aesthetics means kind of like aesthetically means like artistically, creatively, like how it looks beautifully. That's aesthetics, like how it looks to you. Okay. It says for me to do this one, but I think that's enough. Ad nauseum, right? That's enough. Bye bye. Turn them both into fractions, by the way, and then multiply and then reduce and simplify and improper divide, all that, divide, multiply, subtract. Where does the remainder go? Red. Remainder goes on top. Where does the divisor go? Color coded it. Blue goes on the bottom. Bye. Bye. Bye starts with B too. Bye.